Okay, then we'll start. As I said, my name's Gavin Newlands, and today I'm going to be talking about the model build functionality within Oasys PRIMER. And this is an introduction to two parts, really. The first part is I'm going to be talking about the database template system that you can use within PRIMER. And the second part is talking about the model build from CSV file functionality that also exists within PRIMER. So let's start. So what's the motivation behind adding in this functionality into PRIMER and also using it? Well, if we consider that the slide we have here, you can see there's a complex data management problem. So if you're working in the automotive industry, you might have one vehicle model and many load cases that you want to set up from that. And this is just a simple example where you might have some front impact, you might have some side impact, side pole, movable barriers, rigid walls, roof crush, etc. So how do you manage that data? How do you manage the situation where you want to set up multiple models from multiple load cases, should I say, from one vehicle model? So you want to manage data for many LS-DYNA load cases. So problems that could come up are things like there's different loading conditions. So you have different barriers, different initial velocities, that sort of thing. And also different model contents. So if we think about a side impact compared to a front impact, a side impact will have a different dummy model to a front impact, different dummy position, so that means a different seat, maybe different seat belts with different fire times, and so on, and maybe different vehicle variants as well, so the content of the model can change. You might have different measurement devices and output requests. So for example, for a side impact, you might want to measure something different to a front impact. For a front impact, you might want to measure intrusion. So you might have some intrusion springs or something like that. For a side impact, you might want to measure intrusion from the side panels going in the Y direction. Different control parameters. So an obvious one there is the termination time. So you might want to set different termination time for different load cases. And you might have different versions of components. So sort of classic example is if you're running a front impact, the rear doors of the vehicle, you might not need to have a really detailed door model. You could just have a coarser mesh or maybe a mass representation in there. But for the side impact, you might want to use the more detailed model. So if you have a system in place where you can automatically build models in a consistent way, such as the database template system in PRIMER, you can easily update the models of all load cases where the design has changed. You can avoid errors when updating the model. So things like adding in new parts into your model, they might be omitted from a contact or something like that. You can avoid these sort of problems. You can easily rerun load cases when studying design improvements. And you can avoid having multiple copies of the same data. So example, having a body in white, a separate body in white model for different load cases. You can avoid that sort of problem because once you have separate models, they can be difficult to update. You have to update both. If there's an error in one, you might just fix it in one place and not fix it in the other one, and so on. And also allows large teams to work on models simultaneously as well. So the first part here is I'm going to talk about PRIMER's database and template system. So this is the concept. So out of the two things, the database and the template, this is the database. Now this is a very simplified example, but the database is essentially a storage place for all possible include files in the models that you want to build. And as I said, this is a simplified case. You'll very likely have much more include files than you see on the screen here. But you can see here we've got a vehicle model, we've got door include files, we've got barriers, and we've got occupants, we've got seats, And then we've got things like control cards, materials, contacts, and so on. So the database includes all the individual include files that you might want to use to build some models. Then on top of that sits templates, and the templates overlay the database. And essentially, you have a different template for each load case that you want to build. And that template will specify which of the include files are required for that load case. So here we've got an example here of a template for an FFB, a frontal crash. So we've got the vehicle, we've got the doors, we've got the engine, we've got the bonnet, we've got certain control cards, we've got a rigid barrier, and we've got a whole vehicle contact. Now if you look at the next slide, here we've got a different template, and this is for a side impact, double IHS side impact. And here we've got a different barrier, obviously, but also in this case including an occupant, a dummy model, and a seat model. And here's a third example, a roof crush template. So here we're including the body in white and the glazing, but we're not including anything, any wheels or engine or anything like that. Got a particular roof crush contact include file we're including here, and so on. So this is another template. So as you can see, we've got a database referencing all the individual components of include files, and then the templates select which ones are required for each separate load case. So that's the concept. So why would you use a system like this? Well, you've got one copy of the data for each component, and it's kept centrally. And that means that if users copy the data for each load case, you might change only one copy, and errors remain in the other copies. So as I was talking about before, if you have a separate body and white model for two different load cases, you might only change one of them and not remember to change the other one. Component data is reused for different load cases. So all the different body and white, doors, bonnets, they can all be reused for different load cases. And we can also ensure that all team members use the correct version and the correct data. So that's an important point. When you have a database and you have a current version in the database, you can ensure that everyone gets the right version. And also built into this, there's some checking and renumbering options that can be applied when you're building your models using this system, which can help you along the way. So how do you, if you want to try this, how do you get started in Primer? Well, the first thing is to try and build a database. And the easiest way of doing this, the database, by the way, is an XML file that you store in your system somewhere. But the easiest way of creating that is, first of all, to create a directory structure with all your include files in on your system. Okay, and you can split that up into different subdirectories and so on. But basically to have one area where all your include files that you want to use are organized into a directory structure. Then in Primer, if you go to Model Build, you can click on Create Database from Directory. And what that does is if you point it towards the top level directory, it will propagate down through all the include files that it can find, all the models it can find, and it remembers the hierarchy, and it'll build a database file from that system. So that's a good place to start. Once you have that database, you then want to use it to build some models. So to do that, in Primer, you go to Model Build, and the option you choose is to select an XML database. And when you select an XML database, you get this panel. And at the top here, you can select that XML file that's been created. Now, excuse me, there's also the ability to put database as separate buttons in this panel as well. So if you've got a database you use a lot, or you might have more than one database, you can add them as buttons onto this panel. And I'll show you how to do that on the next slide. But essentially, when you read the database in, you get a panel that looks like this on the right-hand side, where you have the hierarchy, the directory structure that you set up before, and all the different components are in there as separate entries. So this is how to get that button to appear on the panel. So to make your database appear automatically in the panel, you create a file and you call it OA_database, and you keep that in the home or install area. So if you're familiar with the preferences file and how that works in Primer, you keep this OA database file in the same place as your OA pref file, which contains your preferences. And basically it points towards a database that lives on the system. And when you have that line in there, this button will appear on that panel. Just makes it a bit easier to read in the database rather than navigating for it each time. So you have your database, and you've got to the point here where you've got a list of components that you might want to read in to build a model. So you can go through this panel and turn on the ones that you want. So here we've got an example where we're selecting some standard control cards, output requests, the body and white, suspension, and so on. So you go through, tick the boxes that you want, and you click apply at the top, and that will build a model. It will read those components into Primer, and it will build a model for you. But you don't want to do that each time. Remember that you might have hundreds of these entries. You might have a very complex model, and you don't want to have to go through each time ticking these boxes, because you might get it wrong at one point and miss something out or select the wrong thing. So for a particular load case, once you've selected the ones that you want, if you click on Save Template, highlighted here, you can save that selection out as a file, and then that's your template. So next time you come into this panel, you can click on Load Template, read that in, and that will select the same boxes that you selected last time. So it's a much easier and more robust way of building a model. So that's what you'd do if you were building one model, for example. But a better way is really to use something called the template panel, which is on the right-hand side here at the top. If we go to the next slide, you'll see what the template panel looks like. What you get here is you get a list of all your components down the left-hand side here. Then across the top, you have all your load cases. And it's just a more compact view of visualizing all the load cases and what components they're referencing. And so what's going to happen when you build the models and read the data in. Now in this panel, you can turn these tick boxes on or off to update your load cases and save them all out into one directory. So it's a fairly easy thing to do. You can also add new templates in here quite easily. You can right click on one and do copy, create a copy, and then just modify it. So you want to create a slightly different load case with a slightly different barrier or an occupant in a slightly different position. You can easily do that through here. Okay. Now going on from this, once you've got this set up, there's an option at the top that says Build Models. And this is where you can build multiple models in one go. So from this panel, you might want to build all of these models across the top, all these different load cases. So we've got ECR95, Euro NCAP, a couple of Euro NCAP ones there, FMVSS 208, 314, and so on. Once you go into model builds, you get a slightly different panel. Here we've got all the different templates down here. And then you have the option to either build or write. So what's the difference between those? Well, build will build the model in Primer. Okay, so for each one that you tick in this list, it will build a model in Primer. So if you tick 5 of them, you'll end up with 5 models in Primer. Write will write the model out to disk. So it will write a master file out which references the include files that have been ticked for that particular load case. And I'll show you this as an example in a bit as well. And at that point, you'll have your models. So you'll either have them on disk that you can then submit into LS-DYNA, or you can look at the models in Primer and check them. Now, another important point to note here is that if you wanted to carry out this type of process where you're building multiple models based on a database and template system, you can do it as an automatic operation when running Primer in batch mode. As part of that, it can fit into maybe an automatic process that you have for building models and submitting into LS-DYNA. So when you're running in batch mode, you essentially feed Primer a command file, which is a series of text commands to do something. And for doing this particular operation, when you're building models, this is the sort of text, this is the sort of contents of the file. So you reference the database, you reference a template, you build the model, and you write the model out. And this is repeated for 2 different load cases here. So it's a fairly straightforward thing to do once the database and template system is set up to be able to automate the building of multiple models without actually having to open Primer interactively. A couple of other things you can do within the template, the database panel. There's a button that says View Thumbnails. And what this allows you to do is to create little thumbnail images of each of the different components in your model and display them on this panel. And this is just a visual aid to help you identify what's in those components. And when you save the database out, those thumbnail images will be saved in the database so that when you read the model back in again, read the database back in again, those thumbnails are available. So here we have the database menu. If we're looking at this and we're looking at the component, perhaps you want to update a component from one iteration to another. So let's say your body in white is revision 5 and you want to you've changed the body in white and you want to update the entry in the database to version 6. So you can do that in here. So you basically just right click on the entry in the database in this tree structure. You click on edit and you get a panel that looks like this on the right hand side. And here you can change the reference to the keyword file that is appropriate for this component. Once you've updated the database, you don't need to update the templates. They will still select the right entry in the database when you're building your load cases. So that's all you should have to do. Now, when you're doing the builds, there's different types of build. So I'll just go through what they are. So there's something called master only. So all that does is it writes out a master file to disk, which references the selected include. So it doesn't actually build the model in Primer, it just writes the master file out to disk. The next thing is a simple build. And this is where you will actually do a build in Primer. And it will just build the model from the selected includes, but without any checking. Okay, so if you have label clashes across include files, then this build will fail. Then we have rigorous, which is, as the name suggests, a more rigorous build option. And here it will implement renumbering and check for clashes and attempt to fix them. So it will do a lot more in terms of checking, relabeling, during the model build to try and fix any problems that you might have. And there's another one called component, which is the same as rigorous, but it has extra data files omitted, and I'll explain what extra data files are in a second. So the main two really are simple and rigorous. And so simple, you can just think of it as reading a normal model into Primer. So what does rigorous give you extra? So it adds in renumbering for each include file. And for each entry in the database, you can specify numbering ranges that you want to ensure the contents of are renumbered to. You also get panels that look something like this on the screen, where you're reading a model in, doing a rigorous build, building the model. You get this these check panels which show you where there might be problems when building the model. So things like looking at cross-references. Are there any cross-references between include files that you weren't expecting? Label problems. Do you have contents within a particular component that's outside the range? Has it been renumbered? Also, it will do some model checks as well. So it does a normal Primer check, looking at errors and warnings. element quality checks, some specific contact checks, so looking at penetrations that are in the model. So it gives you an overall view on how well the model build has gone, and also indicates some areas that you might want to fix things in the model. So I'm just going to show you some of this interactively in Primer now. So here we have an empty Primer session. There's no model read in here. And I'm going to go to Model Build, and I'm going to select an existing database file that I've already created. There we go. So this is my database read in. As you can see, there's a tree structure here, and if I click on Expand All, you'll see all the entries in here. So here we've got some general include files, which has some control cards, output request, general contact. And the vehicle include files, we've got a body in white, a long wheelbase version of the body in white, suspension, and so on. I can scroll through these. So I can just build a model by clicking on some of these. And I clicked on apply, it would read those in. Or I can load a template. So I've written an FFB template here. Now you can see it's selected some of these include files. So the template has selected all the ones required for this particular load case. And again, I can click on apply here to build that model. But before I do that, I'll show you the template panel. So if I come into the template panel and I select one particular template in here, it selects all of them. Selects all the templates in the directory that you point it towards. And as you can see here, I've got all my components down the left-hand side. And across the top, I've got 1, 2, 3, 4, 5 different load cases. So I've got an FFB with a long wheelbase, double IHS, and so on. And these have selected different include files. So I can change these in this panel, save them all out, add new ones in here by right-clicking and to create a new one or copy, and so on. So it's quite an easy panel to visualize what's going on and to set new load cases up. Okay, let's say I wanted to build these models. I can now click on Build Models at the top. This is where I get the panel where I've got all my templates and load cases down the left-hand side here, and I can select whether to write or build them in Primer. So I'm just going to build these in Primer. So I select these ones. I'm just going to do a simple build. So if I click Apply, it starts building the models. So it's reading in the components for each of those load cases and creating a separate model for each entry, for each template that I've selected. Now, if you just watch here as well, you'll see that there's a barrier in a second with an ODB frontal impact being positioned against the, here we go, you see it's been moved to the side and moved into position. I'll explain that in a second. Okay, so that's built those 5 models. If I quit out of this, you can see now, hopefully, in Primer, I now have 5 models, one each for each of the templates that I selected that I want to build. So the first one here is an FFB front impact model. The second one is the same load case, but a long wheelbase, so selecting a slightly different variant of the vehicle. The next one is double IHS, so this has an occupant model in, and a seat belt and a seat, and a side barrier. Third one is an ODB, so this is one where the barrier has been positioned, and I'll explain that in a second. And finally, we've got a roof crush, where we're just selecting the body in white and the glazing, and we've got the roof plate for crushing the roof. Okay, So some other more advanced features to this. So you saw an example of this when I was doing the model build. You can position components during the model build process as well. So this is for situations where you have a barrier and you might want to position it at different locations for different load cases. So the way this works is you define a master orient point, and that's usually a point location on the vehicle somewhere, and you give it a certain name. So let's take this example as an ODB reference point. Now this is stored in the template because the position on the vehicle is usually determined by the load case that you're setting up. So it stays with the template, and the template defines the load case. And then you also specify an equivalent slave orient point on the barrier model. And so when building the model, the barrier is moved using an include transform, so that the slave point in the barrier moves to the master point in the vehicle, and then the barrier model is depenetrated from the vehicle along a defined vector, and that vector is also specified as part of this. So you end up with a model that is positioned correctly and also depenetrated correctly. Now, so far I've just been talking about these components as include files, reading in different include files, but you can specify different component types. So the default really is a dyna keyword, but you can specify a nastran file as well. Primer can read nastran data and convert them into LS-DYNA data. Excuse me. You can also specify connection XML files. So if you create connection entities in Primer, so spot welds, bolts, adhesive, you can save that connection information as an XML file, and that can be a component within your model build process. And if it is an XML file, what happens is that when you do the model build, the data within that XML file will be used to create connections. So here's an example of that. Here we've got the database contains separate parts that aren't connected. It also contains this XML file. During model build, these parts are joined together with the information that exists within that XML file. Now, another optional thing you can do with these components is you can add extra data files, which can be thought of as other include files that are associated with the main component. So here we've got an example where we have a component which is a body in white, so we're referencing a body in white keyword file. But it may be beneficial to keep certain things in separate include files that's associated with the master include file. So things like connections or contacts or something like that. So the contacts maybe or connections between the body in white and some other file can exist as a separate file, and it makes it easier to work with that sort of information if they're separated out. Now, version control is also something that is built into the model database template system. And version control allows you to keep track of the development of component models during a project. So, as an example, a body in white might have, say, 50 different versions as the development progresses. And those can all be stored under the database component entry. And then the user can select which version they want to use for this particular build. So here you can see I've got a select version option here where you can select a particular version or type in what version you want to do for a particular component, and that will select the appropriate keyword file. Version control can also be used to easily build an earlier version of the model. So let's say you've got version 3 of your model and you've moved on to version 10. You can quite easily build version 3 again just by selecting, I want to build version 3, please. And Primer will do that for you. When you're changing from one version to another, you can type in comments and they're stored and allow you to track the changes. And those will be written out to the master deck as well to allow you to keep those comments with the keyword file. Now, I mentioned this previously, but you can also set numbering ranges for each component in your database. And this is then used, as I said, during the rigorous build. So if any entity lies outside the range, it will be renumbered correctly. There's also a frozen range here, which is quite useful for preventing things from being renumbered during a build process. And that might be database history nodes you might want to prevent from being renumbered. So you can specify a range to put those in here, which can help. So I'll just quickly go through this. This is just some good modeling practice when working with these sort of automatic assembly processes to help avoid errors. So I've touched on this before, but essentially you want to try and prevent any label clashes. We do have tools built in Primer that allow you to check this and try and renumber things automatically. But it's good to work to a system to start with. So people tend to set up numbering ranges for elements and other entities within their model for the different components. And as long as you adhere to that, you'll avoid all these label clashes that you can get in a dyna model. So barriers, you might just have one entry in this one numbering range for barriers, because you usually just have one barrier in each separate load case. But for dummies, you probably have to have a different numbering range for a driver's side and a passenger side and a rear child, or whatever it may be, because you quite often want to include all of those in the model. Now, in terms of contacts, it's not a good idea to create a general single surface contact for the whole vehicle using a part set list. It's quite prone to getting things wrong. If you add new parts into the model, you have to remember to put them in the list, and so on. Much better to use a part set list generates. That's where you specify a start and end range, and anything between those two numbers will be included in the model. So here's just an example of that. We've got a range here for the seats, a range here for parts in a powertrain, a range here for parts in the body structure. And these ranges can be set such that maybe the top part of your whole numbering range are where things that you want to exclude from the part set live. So you might want to include solid spot weld parts, things like that, in the upper part, and avoid having those in your in contact that way. Another way of doing that is to use type 6 for an automatic single surface, and that's an excluded part set. So there, everything is included apart from the stuff that's specified in the part set. So that's another way you can specify. You can use a part list generate for that as well. Some contacts need to include only certain parts. So, for example, a dummy to airbag. So they can be created in the usual way. It's only really the bigger contacts where you have to think about adding and subtracting parts. In Primer itself, there are quite a few options for setting up numbering ranges just generally. It's a panel that looks like this. So for each different include file, you can specify numbering ranges, and Primer will automatically check if any entities are within those range, or if they're out. If they're out, it gives you the option to renumber them. Also, when you are creating entities, in particular include files, they will be automatically given labels that's appropriate for the include file that you're creating it in. Connections can be a bit difficult particularly when you're looking at connections between one include file and another include file. And generally, the reason for that is you want to have the ability to modify include files independently and not have to worry about breaking the connection between the include file that you're modifying and anything else in the whole model that you're working on. So node ID references across include files are generally not a good idea. So if you have a nodal rigid body that's connecting together two include files, that will generally go wrong. Again, using a set node generate for various different connection types is often a more robust method. Or part set. So here we've got an example where we have an include file. We've got connections that live within that include file. As long as the connection lives within an include file, then you can pretty much connect it in any way you want. So having nodal rigid bodies is fine. You can use part-based connections, so things like constrained rigid bodies or extra nodes, that's fine. So as soon as you start connecting things across include files, that you can come into problems. So here we've got an example where we've got maybe a nodal rigid body that references a node on one side and a node on the other side. It says forbidden here. It's perfectly reasonable. It's perfectly possible to create that, but it can be a bad idea because it can lead to problems further down the line and errors that you might not pick up. It's much better if you're connecting between two include files to use some sort of part-based connection. So here we might have a constrained rigid body that's connecting together these two parts, for example. And what's often even better is for those connections, instead of, this is the previous example, these connections live in one of the include files, is that these connections live in a separate include file. And then, so this would contain maybe the constrained rigid body or the extra node, and then the things that are referenced live in the individual include files. And that keeps include file 1 and include file 2 here completely self-contained entities. So that was the first part of this talk. That was talking about the model build database template system in Primer. So the last part of this talk today is talking about another option that lives under model build, which is building models from a CSV targeting file. So what is this? This is for situations where you want to take an impactor and position it lots of different times on your model. So good examples in the automotive world are things like pedestrian impact, maybe interior head impact, so FMVSS 201 upper, things like ejection mitigation, that sort of stuff. So this functionality is used to set up multiple impacts on an object in different locations. An impactor is positioned and depenetrated at each of the specified target points. And when you're doing this, a new model is created for each target point, and it uses include transforms rather than creating different models for each different impactor location. And then that's all set up in Primer, and then you can use the Oasys shell and Oasys reporter to either batch submit all these runs in LS-DYNA and to automatically post-process the results as well. So Primer automatically creates dyna input from 3 files. So you've got the impactor file. So here we're looking at the example of pedestrian impact. So this is our impactor file. Positioning file, which is this thing in the middle, and a vehicle model, which is here. And then that will produce many, many different models here. So you can see to the right here, I've got lots of vehicle models, but the head form is in different locations. So the vehicle file and the impactor file is something that you'll have. The positioning file is something that you need to set up. So this positioning file here can either be set up in Primer interactively, and saved out as a CSV file, or you can set it up in Excel and then just read it into Primer. So this is what the positioning file, the targeting file looks like. Essentially at the top here, you have the type of load case that you're looking at. So this is ped head, pedestrian head impact. You reference a model and an impactor. There's information here on the orientation of the impactor. We're going to be moving this impactor around in a local coordinate system, and we need to know some sort of information as to what that local coordinate system is. That's how it's defined here. You've got some information as to where the output files will be written. Then we've got depenetration information. So this is when you position the impactor. Generally, you will have to depenetrate it from the vehicle that you're positioning it against. So that's information here. And then finally, at the bottom, you've got the load case line. So these are the target points. So it's the list of the target points that you want to move your impactor to. So the general process here is you would go to model build from CSV targeting file, and you get a panel that looks like this on the right-hand side. So on this panel is where you can interactively set up the information required, or you can click on Read CSV at the top to read that information in. Generally, the first time you did this, you'd come into this panel and set the information up, write it out, and then the next time you use it, you'll just read that CSV file in, or you might want to add in new target points. You could do that in Excel and so on. But the first time you come in, you probably set this information up using this panel. So I mentioned that you can specify different build types, and some of those are geared towards particular load cases, and they do slightly different things. So there's HuaiHai, which is interior head impact, which is free motion head form type work. Pedestrian head, which is pedestrian head impact. Head angle is a slight variation where you might want to specify a different head angle for each of the load cases that you build. Head lower is for pedestrian impact, lower leg, and then there's upper for upper leg. There's a slight variation on that, which is head leg upper 2, where you can specify an explicit Z coordinate. Then the rest of them are kind of general ones that you can use for general impactor. So they don't have any specific load cases in mind, but there's one that just does a general translate rotate. There's one that relates to a triad, so you specify a triad on the impactor and on the vehicle, and you can move the triads to a line. And there's one where there's a vector align as well. So they're sort of general ones. So the two main things that you have to set up is the orientation and depenetrate, as I mentioned before. So the orientation, this is where you specify the local coordinate system of your impactor. And there's two ways of doing this. One is to specify 3 nodes. And in this case, node 1 is a base node in your impactor. And node 2 defines the local x coordinate, local x axis, should I say, between node 1 and node 2. And then node 3 is somewhere on the XY plane. So that's in the Y direction, and those 3 nodes are required to specify a local coordinate system. Or if you have an impactor which already defines the local coordinate system by having a star define coordinate system, an LS-DYNA coordinate system, you can just select that. Now the next thing that you have to specify is depenetrate. And this is how you want the impactor to be depenetrated during the model build process. And there's three ways that it can depenetrate. One is the x-axis, so this means that once it's positioned into the target point, it will depenetrate just along the local x-axis. Then there's xz plane, so that means it will depenetrate but only be allowed to move in the local xz plane. And then there's xy plane, which is essentially free movement. It can move all the way around when it's depenetrating. And I'll show some images of this on the next slide, which explains it a little bit better. There's also 2 ways of specifying the contact between the impact and the model. So when you're depenetrating, you need some way of specifying what the contact is, so the primer knows how to depenetrate and how far it needs to depenetrate. So you either, in this case, you select a contact that already exists in the model, and the most likely thing is that you will have a contact in there between the impactor and the vehicle, so you just select that. Or if you don't have that contact already in there, you can select just a part set, which is a part set of parts on the vehicle that you want to position to. So this is just showing the depenetration method. So here we have step 1. So let's say we've got our impactor up here. This dark blue line represents the vehicle, so the bonnet surface in this case. So Primer takes the impactor, moves it from its stock position to the target position. So as you can see, it's sticking through the bonnet there. And the next point, it will then depenetrate. So in step 2 here in the middle, this is when we're depenetrating just along the local x-axis. So you can see it's moving back along the local x-axis. And then as soon as it's depenetrated, that's it positioned. So in that case, you can see the initial contact point is further forward than the target point. What you can do instead is maybe depenetrate along the XZ axis. So this means it's free to move in the local Z direction as well. So you can see here, since it is free to move in that direction, our initial contact point is much closer to the target point. And the full XYZ axis option is also available to move freely in all 3 degrees of freedom. So once you've set up the axis, you've set up the depenetration method, you can specify your target points. So you can just click on Edit Load Cases here, and you can pick them from the screen and sketch them. And so once you've done all that, you just click on Build, and it will build a model. And I'll show you an example of this in a second. And so for each impact position, Primer creates a directory for each load case, and we'll write out a master keyword file that uses include transform to position the head form. And it also creates a list of variables for auto post-processing. So at the top here, this is the keyword file that's written out. You can see it references the vehicle model and the head form. And then also there's a defined transformation that's been created here. So that's to take the impactor from its standard position, its stock position, and move it to the target position that you've specified and depenetrated to. But you also get this list file here, and this list file can be used to submit all the analysis into the Oasys shell to run them in LS-DYNA, or it can be used if you want to post-process them all automatically by reading this list into Oasys Reporter. So I'll just show you this as a demo as well. So I've got another session of Primer here. Again, this is an empty session. If I go to build, and this time I'm going to choose build from CSV targeting file, click apply. Now I've got a so I can use this file to set something up. But if I read CSV, I've already got one. Here's one I made earlier. So I read that CSV file, it populates all the information. If I click on make here, it reads the 2 models in, so the vehicle and the impactor. And the impactor is read in its standard stock position, so you can see it's floating in space above the bonnet here. So here you can see the information that's been specified. So the orientation information, so I've got the nodes there, and then the depenetrate information I've got set to XZ, plane, and the contacts defined. If I click on Edit Load Cases, you can see these are the load cases that have been specified. If I sketch all, you can see those points there. And I can add to this and take away as well. For pedestrian impact, you just need to specify an XY coordinate because Primer will automatically project to the bonnet surface to work out what the Z coordinate is. You can specify the Z coordinate if you want, but you don't have to. So now I can build, so I can click on Apply to Build. Now just one thing to note here, there's this delete button. Okay, now this is active at the minute. That means it will build the model, write it out, and then delete. Build the model, write it out, and delete. The reason it does that is because potentially you could be setting up hundreds of these runs. And if you start building hundreds of runs in Primer, you may run out of memory on your machine. So the delete option is on by default, so that as each model is built, it will delete it from memory and continue on. I'm going to turn that off because I'm not going to build very many models. I'll click Apply, and hopefully you can see the head form being moved to all those different target points and depenetrating, and then it writes out a model. So this just takes a few seconds. There's probably around 20 impact points here. So it's moving that base node to the target point, depenetrating. In this case, it's depenetrating along the XZ plane because that's what I've specified. And then writing the model out at the end. Again, it's not writing out, creating new impactor models. It's writing out as an include transform and referencing the original model. I think it's nearly finished now. Last couple, I think. Here we go. Good. So we finished. Because I selected not to delete, if I go to my model list, you can see I've now got 25 models in Primer. And if I just go through and turn them on, you can hopefully see all the models that have been built, with the impactor positioned at the various different points. And if I look in the part tree, you can see all the include files that exist for each different model, and there's a little red T next to the impactor, and that means that it's part of a defined transformation definition. So that's what's being created and calculated due to the model build process. And those have been written out to disk here, and you can see I've got a different directory for each one, and that's one of the ones that's just been written out. I read that in. You can see there's a defined transformation and the reference to the vehicle and the head form. So similar methods can be used for upper leg, lower leg, head forms, and just general impactors. There's also the options for interior head impact, so that allows you to set different angles for the head form. Also takes into account chin contact and rotating back away from trim. So there's a few more options available for interior head impact for FMVSS 201 upper as well. Okay, so that's brought us to the end of the webinar today. So hopefully that was an informative introduction to some of the model build features within Primer. If you do want any more information on those or anything else, please do contact us. So there's the contact details there. In the UK, that's dyna.support at arup.com. As I said, this will be available as a video, and the notes will also be available as well on our website. And we'll have those up in the next couple of days. I'll just check to see if we've had any questions. No, we haven't had any questions. So with that, I think I'll just bring the webinar to a close. Thank you very much for listening today and your attendance. And I hope to see you again soon at a future webinar. So thank you very much and goodbye.